Okay, so I think I'm at a stage now where I can start to dismantle some of the parts which are allowing me to test the coding and some of the other files in the system directory, and transfer the components into the enclosure. Before I do that, I just want to talk about the last few things that I've done. I've changed over to a 4-channel relay module, and I'm actually using the M80 ATX power on command to trip a relay which actually has the power going through it for the NVR switch over here, which latches when it's pressed and allows the power to the various components. The live cable is wired through the common and normally closed, and when I send an M80 command, which is meant to turn the ATX power on, in this case I actually am able to turn it off remotely. This might be useful if I want to enable the sleep.g file in the system directory with a option to shut the machine down at the end of a job if I'm going to be preoccupied doing something else. In reality, you should always be around when your machine is operating in case something goes wrong. I've also installed the smaller power supply that is powering the Laser CNC adapter. You can see the power LED is on there. Not too happy about using one of these push DC connectors, but I'll work on that and try and neaten it up in some way when I have time. I've still got to do a couple more things with this, but it doesn't make sense to do it until I start to move stuff over and I can actually test the module properly. The other thing I did as well was swap over to these slightly transparent push switches, which have a 24 volt LED part of them as well, which I'm using for which I will be using for the 2 buttons that operate the relay modules for the dust extractor and air filter. When these are pressed, the light turns on and the relay module is energized, and this indicates to me that that's the case. I'm still using normal push buttons for the other ones. And then the last thing I did, if I can push this back, was get a PanelDue 7i from Ooze Nest, and it means I can actually operate some functions closer to the CNC machine, although I'll try and do the majority of stuff through the web interface. As you can see, I can home everything here. I can also stop everything and it can reboot. So there's a lot more information that you don't normally see on the web interface because it's disconnected from the controller, and this is quite nice just to be able to check things on the fly. And I'll make a frame for this which will go on the front of the enclosure itself. There's a few things that are a bit shame about this. It's not really set up for CNC use, so you can still see random temperature readings, and it doesn't tell you what work coordinate you're in, or does it show you the machine position. So may feed that back at some point, but all my macros will be there. I'll be able to move. I have no reason for the extrusion, so this is something that needs to go. I can see the console, what's been going on, and it says print, really should just say job. So there's little things I need to change, but I'm really impressed with this. With the right development, this could easily be a pendant. Anyway, I'm now going to start to dismantle everything, but not before taking detailed photos. I'm now going to shut the machine off using the M80 command. M80, boom, like magic. While I'm photographing stuff in the background, I'll just put this video into context. There was a gap of over 2 months from filming this part of the project because of the lockdown in the UK, and I think I may have even lost some footage, so I apologise about the delay in getting this out. I began by placing the components and back panel into the enclosure to finalise where I was going to drill the openings for the intake and exhaust fans. Once I was happy with the locations, I removed the electronics and drilled a large 114mm diameter hole for the 120mm fans. The one at the top is more or less centered, while the bottom fan is offset to one side. I used a long reach pen to mark through the mounting holes, which happens to be one of my favourite tools at the moment. A pen, can you believe it? After drilling the mounting holes, I installed the dust filter on the outside with the fan mounted on the inside. The bottom fan will blow cool air into the enclosure around the control board, while the top fan vents air out. I then decided the locations of the push buttons, which I was going to place closer to the hinge side of the door. The buttons will go near the bottom, with the touchscreen in the center and the NVR switch and sockets at the top. I've tried to separate the AC and DC voltage to opposite ends of the enclosure, but I've noticed that professional machines generally separate the back panels in the enclosure, so those components are ground and drained separately. Not something that I was able to do in this enclosure. If I haven't mentioned this already, these buttons are from RS Components and are modular, which make them a lot easier to install and maintain. I'll talk a bit more about them at the end of the video where I explain the wiring. To fit the NVR switch, I drilled 4 holes at the corners and used the oscillating multi-tool to cut out a window. I then deburred the edge using my pipe deburring tool. I have to admit, the nice thing about the clear panel window was I could easily trace where I had to drill mounting holes. That said, the controller is going to look a little bit boy racer, homemade computerish, but if it gets too embarrassing, I could always put a thick curtain up in front of it. The final thing to do was cut the openings for the plug sockets, which I installed in a similar way. And then by some magic of cinema, I cut away to the enclosure mounted to the wall and more or less wired up. I said by the magic of cinema. By the magic of watching YouTube in your underwear on your couch. So everything's in the enclosure now, and I've wired the buttons, the screen up, plus the power plugs and the NVR switch. And I'll just briefly talk about what I've done. Here you can see I've wired the neutral to the different plugs, including the earth, which goes back to this end up here, and the live goes back into the enclosure to these 2 relay modules and then back up to these 2 plugs. I've already got one space utilized, which is to this extractor over here, and they are operated either through software, and as I mentioned earlier, these 2 switches here. The PanelDue 7i screen is being mounted onto a Velcromat frame, and what I've also done is place some Kapton tape on the back to help with static from the plastic. I've got a hole here for the Molex connector, and I've looped the cable, which is shielded, through this ferrite core, and to the relevant connector onto the Duet too. And I used a couple nylon spacers just to make sure that the screen was held in the correct position. I should also add, when I was using the provided ribbon cable with the touchscreen, I found I was getting some kind of interference which affected the controller's behaviour, and this went away when I moved to the shielded cable, despite not properly draining the shielding on the cable. But with the ferrite core, so far I've had no problems. Below that are the various buttons and switches. You can see I mainly used the yellow wire to do this. It would have been nice to have some numbering systems in place so I could have labelled everything up, but you can also check the wiring using a voltmeter, and this is why it looks the way it does. I may get some cable markers that clip onto the wires and do something retrospectively, but I don't really know too much about numbering conventions for electronics, so if anyone has any suggested reading, please send them my way. What I like about these connectors and buttons is that you can have up to 3 different blocks at the rear, either normally open or normally closed, or 2 plus a LED light, which you can only use if you have a translucent face to the button. For example, this emergency stop here, the pair of yellow wires goes to the relay module through this barrier block and then onto the relevant connectors under here. But I also have a pair of brown wires which travels along there, up here, and into the terminals for the Laser CNC adapter. One pair of wires is for the emergency stop, and the other pair goes to this switch, which should really be a key switch for arming and disarming the laser adapter. It gives me the option, the failsafe, to make sure it won't run here, and also on the controller adapter itself over there. I've also wired the steppers and the limit switches, which I've labelled on the inside here. You can see the limit switches here, and I've wired the limit switches through these glands on this side. There's 5 of them, and this wire here goes to the probe, which is over here. On the machine itself, I've made a few changes with how I connect everything up, and I've moved over to these 2-part connectors, which make the whole process a hell of a lot easier. I don't have to worry about soldering anything. They clip in place, and it would be pretty difficult for them to come apart by accident. And I've done that for all the stepper motors. I'll just show you the controller turning on. The fans are a little noisy, so I will rewire those either with a resistor to slow the speed down, or more likely to the spare fan headers on the Duet, which I can control the speed either manually or based on the internal temperature of the enclosure, which is entirely possible with the Duet. So I think this video has lasted long enough. I still have many things to work on, and these include reprogramming connecting the VFD to the spindle, walking through the tool touch probe workflow, setting up the Laser module, working out how to control the tangential knife, building an enclosure around the CNC machine, and probably more, because I really like to drag these things out. If there's anything you'd like me to address in future videos, please mention those in the comments and I'll see what I can do. Otherwise, thanks again for sticking around, and to my magnificent patrons, and you'll catch me in the next one.